Welcome to all. Today we will be discussing the new chapter, Unit 3, the theory of relativity. Before going to discuss the theory of relativity, first of all, we will have a brief description about the events that happened in the history that led to the theory of relativity. As all of you are familiar, there were different theories about the nature of light. And these theories about the nature of light was the key factor that led to the theory of relativity. In 1675, there was the corpuscular theory of light, in which light was assumed to be particles, and this theory was formulated by famous Sir Isaac Newton. Around the same time, there was another theory formulated by Christian Huygens, in which the light was considered to be as a longitudinal wave similar to the sound waves. Later, this theory was modified as the nature of light was transverse wave. Then in 1864, another theory called electromagnetic wave theory of light was formulated by James Clerk Maxwell. And this theory is a milestone in the history of physics. And it is one of the factors that led to the theory of relativity. And in 1900, there is the currently accepted theory called the quantum theory of light, which was formulated by Max Planck. And this theory in a way mixes both the particle nature and wave nature of light. It is called a dual nature of light. So in this chapter, we will be discussing the events happened between 1864, in which electromagnetic theory was published, and in 1905, in which theory of relativity by the most famous scientist Albert Einstein was published. According to Maxwell's electromagnetic theory of light, he found that theoretically the velocity of light in vacuum is 3 into 10 raised to 8 meter per second. It will be represented by the letter C. And as you know from the first chapter on frames of reference, in physics, everything is to be measured with respect to some frame of reference. So naturally, a question arises here. With respect to which frame of reference is this velocity measured? The velocity of light in vacuum is 3 into 10 raised to 8 meter per second, and vacuum is nothing. There is nothing there in vacuum, so that we can measure the velocity with respect to something, but vacuum is nothing. So it was a problem with respect to which this velocity is measured in vacuum. For example, we see that the velocity of sound is 330 meter per second in air. It means that this velocity is measured with respect to air. So air is the medium in that medium sound moves. So the velocity of light is measured with respect to the medium in which it moves. And also sound cannot move in vacuum. It requires a material medium. It is the similar case in the case of water waves in water. It moves on the surface of water. And in a structured string, the waves in a structured string moves on that string. In every case, some quantity is varying, and that varying quantity is supported by a medium. So another question arises here, which medium helps the light to move in vacuum, because vacuum is nothing. So this was a problem in front of the physicist after the publication of Maxwell's electromagnetic theory. Then there was either hypothesis. Actually, either hypothesis was present even before the publication of Maxwell's electromagnetic theory. So after the publication of Maxwell's electromagnetic theory, it becomes more predominant. This hypothesis was to answer the above questions, that is, with respect to which the velocity of light is measured and which medium helps the light to travel in vacuum, these questions are answered by the scientists by postulating a hypothetical medium, and they postulated that a hypothetical medium called ether exists in all space. It was supposed to fill the all space, including vacuum. And there is a fixed frame of reference. They supposed that there is a frame of reference in that ether with respect to which the velocity of light is 310 raised to meter per second. So the velocity of light in all directions in that medium is same, that is 310 raised to meter per second. This was the hypothesis, and this hypothesis is called ether hypothesis. The ether hypothesis was a topic of considerable debate in the history of physics, because it required the existence of an invisible and infinite medium. At the same time, nobody has found that type of medium, so it should have no interaction with the physical objects. So it was contradictory. And also, as the nature of light was explored, especially in the 19th century, the ether hypothesis becomes more and more contradictory. One example is to explain the high velocity of light. We see that the velocity of waves in a medium is root of k by rho, where k is the modulus of elasticity and rho is the density of that medium. For example, in the case of air, it was root of b by rho. B is the bulk modulus and rho is the density of air. So similarly, in ether also the velocity, if it is supposed, that is, if ether is supposed to be a medium helping the movement of light, then the velocity of light should be root of k by rho, where k is the modulus of elasticity. So as the velocity of light is very large, the modulus of elasticity of ether should be very high. At the same time, the density of that ether should be very small. So the density of ether was supposed to be vanishingly small, while its elasticity was supposed to be quite large. So it was extremely contradictory, because a medium with a very high modulus of elasticity but having very small density is not imaginable. And by the late 1800s, the existence of ether was being questioned, but there was no physical theory to replace it, because scientists were so much believed that light requires a medium for its movement. So ether hypothesis was there. But we can see that the earth is moving in space, so it will be also moving with respect to ether. So the velocity of light measured from earth will be different at different times in either in a year, because we see that the earth is moving almost in a circular orbit. So sometimes it may be moving parallel to the ether and with the velocity of light. Sometimes it may be moving anti-parallel to the velocity of light. Sometimes earth may be moving perpendicular to the velocity of light. So the velocity of light can be measured at different time intervals in a year from earth, and if either exists, there will be different results for the velocity of light. Because if the earth is, suppose the earth is moving at a speed v opposite to the propagation of light, then the velocity of light as measured with respect to the Galilean transformation of velocity, it will be c plus v, because earth is moving with a velocity v opposite to the light, so the relative velocity will be c plus v. That is velocity of light with respect to earth. If the earth is moving in the same direction of the propagation of light, then the velocity of light as measured from earth will be c minus v. So ether was assumed to be, ether was assumed to be a preferred inertial frame of reference in which the velocity of light will be c in all directions, and in all other frames of reference the velocity will be different with respect to either c plus v or c minus v with respect to the relative motion of that frame of reference. But what happened? There was a famous experiment called It is called the most famous failed experiment in the history of physics. And this experiment was performed by Michelson and Morley in 1887. And this experiment was performed to determine the speed of Earth with respect to ether. And they devised the experiment using the interference theory of light. And the result, they performed the experiment many times by using many conditions. But the result was conclusively negative. That is, there is no significant difference between the speed of light in different directions. The light travels with the same speed in all directions. It was the result. So that result was negative. There is no either wind. And this is called the most famous negative experiment. So the negative outcome of Michelson-Morley experiment suggested that there was no either. So the either hypothesis was rejected. And this rejection of either hypothesis was confirmed by subsequent experiments in 1920s. And this rejection of either hypothesis led to considerable theoretical work. And a major breakthrough of this was the theory of relativity, which could explain why the experiment failed to see either. Rather, in another way, that relativity said that either is not needed for explaining the velocity of light. So the either hypothesis was rejected after the Michelson-Morley experiment, and it was beautifully explained by the theory of relativity. Michelson-Morley experiment, although the result was negative, it was one of the famous experiments. Along with the black body radiation and photoelectric effects, and also the radioactivity and many other findings in the 1900s or in the later 1800s, was a key experiment in the development of modern physics, which includes both relativity and quantum theory. These are the two wings of modern physics. And here in this chapter, we will discuss the theory of relativity. So thank you for watching this video.